Okay, in this tutorial we're going to talk about powers raised to powers. So a little different concept. We're going to go right to it with an example of what I'm talking about here. So 3 squared in parentheses all to the third power. What that looks like. 3 squared times, that's once. 3 squared, that's twice. And 3 squared, that's 3 times. So, how does this all work out, basically? We've got 3 that's being multiplied, 3 squared rather, being multiplied 3 times over. You can go ahead and add 2 and 2 and 2, and that gets you 3 to the 6th. So you're kind of using the laws of exponents rules with the product. The product rule we learned about earlier. We'll realize that a power raised to a power is multiplying 2 times 3, which is 6. This is different. This is not the same thing as this. So not 3 squared times 3 to the third. Because what is that? What is 3 squared times 3 to the third? That's 3 to the 5th. Okay? Let's make it a little neater here. 3 to the 5th. That's different. Okay, so be aware. This is not the same as this. Okay, let's do another example here. Power like x to the 7th raised to the power of 2, or x to the 7th squared. What that looks like is x to the 7th times x to the 7th, which of course 7 and 7 is 49. Or is it? No, you would actually just say 14. Remember, you add them, add and add. Or 7 times 2 is 14. It's different. It's not the same as this. I hope I'm not confusing you. X to the 7th times x squared is x to the 9th. See? Different. Okay? Different. How about x to the third raised to the 9th power? What does that look like? X to the third, once, twice, 3 times, 4, 5, 6, 7, 8, 9. That takes a lot of work, right? Or just do 3 times 9, which is 27. Or you can go ahead and do it like we did some with the product rule. And that, of course, is going to be 3 plus 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 3, which is 27. It is not the same as this. This is different. Right? That would equal x to the 12th. 3 plus 9 is being multiplied is 12. This is, in parentheses, power to a power, multiply. One more. Power to a power, x to the first to the power of 9. That's x to the first 9 times. 5, 6, 7, 8, and 9. Of course, that's just going to be 1 times 9, which is x to the 9th. How many x's do we have? 9. Okay? Versus x to the first times x to the 9th. That's x times, and then we have 9 x's. 3, 4, 5, 6, 7, 8, 9 x's, which makes how many x's? 10. Different. Okay? I'll give you a couple questions to work on here, and then that'll be it for this little tutorial. This is powers to powers, or a power to a power. Okay? So try these. And when we're done with these, I'll tell you what, we're going to go back to that worksheet we were working on earlier in this lesson, in this assignment, and we'll finish out that page. Alright, first one, 3 times 4, power to the power, x to the 12. Y to the 22nd, and z to the 3rd. That's power raised to a power. Alright, so you remember this then, right? We are looking at 12 now, 13, 14, 15, and 16. Let's take a look at 12. 12 says 2x squared to the power of negative 4. Okay, we'll deal with the negative for now, and then we'll worry about simplifying it, making it more simplified at the end. So basically what I'm talking about is we need to do, well, I'll tell you what, this part we just studied, right? Power to a power, this is going to be x to the negative 8, but we really didn't study this coefficient part. So let's talk about the coefficient. 2 to the power of negative 4. It's 2 to the power of negative 4. Okay, so we have 2 to the negative 4th and x to the negative 8. That's going to be, now we've got to drop both to the bottom, so they're both currently in the numerator. Drop them to the bottom, because everything is going to drop. All we have is 1 on top. Okay, so everything is down to the bottom, 2 to the 4th and x to the 8th. And the only thing on top is 1. 1 basically was there to begin with. Okay, now 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Alright, 16 here, 16 right there, and x to the 8th. So our final answer is going to be 1 over 16x to the 8th. Okay, this is a tough one. These are very tough. Hang in there. Hang in there. Alright, number 13, we have 4r to the 0, all to the power of 4. Alright, so r to the 0 to the 4th. 0 times 4 is 0, so r to the 0 is going to end up just being 1. 0, the law of 0 there, or exponent law of 0. We also have the coefficient there, coefficient which is 4. 4 to the power of 4 means 4 to the power of 4, which is 16, or I'm sorry, which is 264. So 264, and don't mind the noise in the background, that's my dog drinking water. 264, and that's it, because the r to 0 became 1, so you're not going to put times 1, you'll just leave it as 264. Number 14 is next, and we have 4a to the 3rd, all to the power of 2. So a to the 3rd squared is a to the 6th, power to a power, you multiply. Don't forget about that coefficient, 4 to the power of 2 as well, which is 4 squared, which is 16. That is 16 a to the 6th. Number 15, we have 3k to the 4th, all to the power of 4. So everything inside the parentheses for number 15, 3k to the 4th, everything to the power of 4. K to the 4th to the 4th is k to the 16th. And don't forget about the coefficient, 3 to the power of 4, that's 3 to the power of 4, which is 3 times 3 times 3 times 3, which is 81. 81k to the 16th. Okay, and last, we have 16, which is 4xy. We have that quantity, all to the power of negative 1. So, x to the negative 1. Right, isn't this just a 1 right in front there? So 1 times 1 is negative 1. Same goes for the y to the 1, which is y to the negative 1. And then 4 to the negative 1 is 4 to the negative 1. Everything here is the negative 1, which means in the numerator we'll just have 1. Everything else is dropping. This is all dropping to the denominator. So as it drops to the denominator, it becomes positive. 4 to the 1, x to the 1, y to the 1. Let's clean that up a little bit here. Cleaning it up, it's 1 over 4xy. And there you have it. I'll see you next time. Nice job today, folks.